Okay, exercise 2.08, direct linear variation. If y varies as x, or if y is directly proportional to x, now what we mean by directly proportional or varies as x means that if when x goes up, so does y. So that's what that means. If something's directly proportional to something else, then when x gets bigger, y gets bigger, for example. So that's what we mean by directly proportional to x. That means if y, actually it says it here. So a direct linear relationship exists between x and y if x increases, y increases, or if x decreases, y also decreases. So if x goes up, y goes up, or if x goes down, y goes down. So they're called directly proportional to. Okay, so for example, if x is doubled, y is doubled. Or if x is halved, y is halved. You might want to put them two together. So if x increases, y increases, or if x decreases, then y also decreases. Or we could say if x is doubled, y is doubled. So that's a direct proportion. Or we could say in another color, if x is halved, y is halved. Okay, so if x is halved, then y is halved. Okay. Okay, now there are some steps for solving linear variation problems. First, you have to identify your two variables, for example, x and y. And when you know that there is a direct linear variation, so if one of them goes up, so does the other. So in other words, it'll look like this. As this one gets bigger, so does that one. Okay? So you have to identify your two variables, let's say x and y. And if one is directly proportional to the other, then we know that they form a straight line graph like this, and the equation will be y equals kx, which is like y equals mx, but there is no plus b, or the plus b is 0. So it'll form the equation y equals kx, which is really like y equals mx. Now that k is going to be the gradient. Now the way that they will often give you some values for x and y, which you can substitute in, and then you can find k, which is called the constant of variation. Okay, now that k, the constant of variation, is really just the gradient of your line. Then once you work out your k, you'll write your equation again, y equals kx, using your value of k. And once you've written an equation for y in terms of x, you can substitute any value x or y back into the equation and solve a problem. Look, that might not make much sense to you at the moment, but as we solve problems, we're going to follow these 4 steps, okay? And we'll come back to them. Okay, here we go. We've got this graph is a direct linear variation. In other words, it's a straight line graph, okay? And it converts kilometers down here into miles, okay? Kilometers are what we use. They're our metric unit for length, and miles is what, for example, in the US, for example, they use miles, and that's an imperial unit of length. So the first question is, what is the equation for m in terms of k? So we can do this like we did our other question and try and do y equals mx plus b, but we can see that the gradient, the y-intercept is 0 anyway. So because we know it is a direct linear variation, we can say, well, we know that it is of the form y equals kx, which is very similar. Now, k is your constant of variation, which happens to be your gradient. So remember, it says identify the two variables, x and y, and form an equation. Now, we normally have y equals kx, but in our case, remember, y in this case is m and x is k. So what we've got is y is m, miles equals k times kilometers, capital K. Now I've got to be really careful here, because this is, I might just write it instead of like with m's and k's. Y is your miles equals k times kilometers. Just happens that kilometers happens to be K as well. Now, that was step one. Identify your two variables, x and y, form an equation, y equals k times x. Then we substitute values for x and y to find the k. So we look at the information in the question, and we have been given the point 80, 50, and that's your xy value. In other words, your x value, remember this is x, so we know that when k is 50, that's big K, by the way, y, or your m, so this is xy, which actually is km, because your x-axis is k and your y-axis is m. Okay, so that's what we're going to substitute for big K, and that's what we're substituting for m. M is 50, so we're going to put it into that equation. So we've got y, which is m, miles. So we've got 50 equals k times capital K for kilometers is, sorry, it's 80. K is 80, sorry. So we've got the point 80, 50. Sorry. So 50 equals K times 8. This is a bit clearer. I don't think I've been very clear. So we can see that 80 kilometers is here, 50 miles. So when kilometers is equal to 80, miles equals 50. So 50 equals this constant K times kilometers. So 50 equals K times your kilometers is 80. And rearranging this, we get K is 50 over 80, or that K is 5/8. Okay, so now this is our equation. This is part A. The equation for miles in terms of K. So miles is equal to K times kilometers. In other words, m for miles equals, now our K is 5/8, and the symbol for kilometers is K as well, unfortunately. So m equals 5/8 times K, or 5/8K. Now that we've got our equation, we can use it to convert 115 kilometers to miles. So for part B, m equals 5/8 times kilometers. So we're going to sub 115 kilometers, we're going to sub 150, K is 115, to find m. So it's 5/8 times 115, which is 71.875 miles. And for part C, we have to convert 160 miles to kilometers. So when m is 160, you have to find K, is question mark. So we get 160 using the equation equals 5/8 times K. So multiplying by 8, we've got 160 times 8 equals 5K. So that's 1,280 equals 5K, which means that 1,280 divided by 5 equals K. So we get K is 256 kilometers. Okay, so let's just have a look at how those results look on the graph as well. So 115 kilometers is about 72 miles. So let's have a look. So what do we say? 115 kilometers, roughly about here, about there, is 72 miles. That looks good. And the other one is 160 miles. Now that is off our graph. 160 miles. We can't read that, which is why we would need the formula to work out 160 miles. Well, that's 256 kilometers, and that makes sense because 160 miles would be all the way up here. And yes, that's beyond 160 kilometers. Okay. The graph below shows the fuel consumption of two models of Ford cars, Fiesta, which is this one, the blue one, and the G6, okay, which is the pink one. And it says find the equation for F in terms of D. So the fuel, F is fuel, in terms of D, distance travelled for each car. Now we can already see that this Ford G6 has a higher gradient than the Ford Fiesta, so it uses more petrol per kilometre. We can already see that. So we're expecting the Ford G6 equation to have a bigger K or a bigger gradient, okay? So let's just look at the Ford G6 first, which is the pink one, okay? I might just write that in pink as well. Okay, now we've got some values on our graph, 592. So that is your X and your Y value. Instead of XY, that is your D and your F value. So remember, instead of X-axis, we've got D, and instead of Y-axis, we've got F. So 592, D is 500, F is 92. So it is a linear relationship. It's a linear, direct linear proportion. So we can say that Y equals mx, sorry, Y equals kx. We don't use m for these. So Y equals kx. But we don't have Y, we've got F equals k, and we don't have x, we've got D. So F equals k times D. Remember we said that we could see, we're going to substitute D is 500, F is 92 from our graph. D is 500, F is 92 from the graph to find K. So remember, step one is to write the equation. That's step one. Step two is to find K by substituting your D and F value. So F is 92 equals K times 500, which means that K will be 92 divided by 500. You can just get a nice simplified fraction on your calculator, and we get 23 over 125. Okay, or as a decimal, it is 0.184. You only will write it as a decimal if it's a if it is a terminating decimal, and it is terminating, it finishes after 3 decimal points. So therefore, our equation we know is F is K times D, or it's F equals 23 over 125 times D. Or we could write it as F equals 0.184 times D. Either equation is fine. Now, we're going to write the equation for the Ford Fiesta. Okay, looking at some values that we know that again the equation is Y equals KX, or in this case, instead of Y, we've got F equals, so we've got F equals KD, or K times D. We're going to substitute a value that we've got, and we know that when the distance traveled is 450, that the fuel consumption is 30. So we're going to substitute those in. So we've got 30 equals K times 450. In other words, K will be 30 divided by 450, which is, just putting it as a fraction on your calculator, 1/15th, and therefore the equation is F equals 1/15th times D, or you could write it as D over 15, okay, because 1 times D is D over 15 times 1 is 15. As a decimal, I would not be writing that one as a decimal, because you can see you get 0.06 recurring, and you'd have to write it as that. So it's much better to leave it as a fraction. Now for part B, it says to calculate how much more fuel is used by a Ford G6 than a Ford Fiesta over a distance of 100 kilometers. Look, you may be able to read it off the graph, okay, but it is a little bit, well, I suppose you could read it from here, but you can't read the values very well. So for 100 kilometers, this only uses, I can't really tell, about 6 litres, and this one uses almost 20, but you can't read it exactly, okay? So you should use the formula. So now I would just use the 100 kilometers, obviously, for the first one, because they're asking that. Then the second one is asking over 280 kilometers. So for part 1, we're going to substitute D is 100 into both formulas. So for the G6, the Ford G6, we get F equals 23 over 125 times 100. And for the Fiesta, we will have F equals 1 over 15 times 100. So this is the amount of fuel used. And we get 18.4, and the units are litres, and the Fiesta uses 6.6 recurring litres. So the question was how much more fuel is used. So the G6 uses, and you'll just have to subtract the amounts. So you've got 18.4 minus 6.6 recurring litres, and we get 11.73 recurring litres. So the G6 uses more fuel, that much more, 11.73 litres per 100 kilometres, or over 100 kilometres, okay? Now for part 2, it's asking how much more fuel is used by the G6 than the Fiesta over 280 kilometres. Look, we can see they're straight line graphs, so it'll use the same amount extra per 100 kilometres. What we can do, we can just, we can do this two ways. We can substitute all again and subtract, or we can just say 280 divided by 100 is 2.8, and we just multiply this answer here we got by 2.8. So the extra fuel used for 280 kilometres is 11.73 recurring times 2.8, and we get 32.853 recurring litres. Now, that's one way of doing it. That's the quickest way of doing it. But if you're not sure, you could substitute again as we did before. So for the G6, the fuel is 23 over 125 times 280. And for the Fiesta, the fuel will be 1 over 15 times 280. And then we can subtract. But you don't need to do it this way. So here I've got 18.6 recurring, and the other one I've got 51.52 litres, and then so the G6 uses, and we would subtract these two values, 51.52 minus 18.6 recurring litres. Sorry, one sec. 51.52 minus 18.6 recurring is exactly the same answer, 32.853 recurring litres. So it does give you the same answer. This is a quicker method. The reason this method works is that it's a straight line. If it wasn't a straight line and the same pattern doesn't happen all the time, it would not work. And now for part C, it says how much further can a Ford Fiesta be driven than a Ford G6 on 50 litres of fuel? Now, you can get a rough idea from the graph. So let's just look at 50 litres of fuel, which is here, right, for this graph. So 50 litres for this car is about, you can drive, I don't know, about 270 kilometres. You actually can't read this one. 50 litres of fuel is over somewhere here. So you have to use the formula. You can't do this from the graph because 50 litres is here. It's at least, it could be something close to 700 kilometres. So we're going to have to use the formulas for those. So 50 litres of fuel and the distance travel. We have to work out distance is question mark for each of the cars. So for the G6, the formula is F equals 23 over 125 times D. So 50 is our 50 litres equals 23 over 125 times D. So D, so 50 times 125 will equal 23D. So 50 times 125, that's 6,250 equals 23D. Which means that D is 6,250 over 23, or divided by 23, which is 271.74 kilometres. Now we said about 270 kilometres on 50 litres, right? Now for the For the Fiesta, we've got F equals 1 over 15 times D, and we've got 50 litres of fuel equals 1 over 15 times D. So that's 50 equals D over 15, which means that 50 times 15 equals D. In other words, D is 750. And we said that it would be, remember when we said, we looked at the graph, we said that it would be beyond about 700 kilometers if you continue that graph along. So the extra distance that you can travel is a lot. 750 minus 271.74. Well, it's almost 500 kilometers. We're getting, it's 478.26 kilometers if we use the formula, and we do have to use the formula because you can't use the graph. Okay. All right, that's that question 5.